we are discussing on the devices, which the technological devices which we are going to use in M2M and IoT technologies. In that, we had discussed how the devices will be there and what actually the device is and what are the components the device will have in it. So that we had discussed, and we are moving further with that devices and share the PPT. Yeah. Now, so in yesterday's class, we had discussed how, sorry, the devices types will be there, the basic devices and advanced devices will be there, and how you can differentiate that with the characteristics of the basic and advanced. As I've given an example of the both the things, including hybrid, will also be there in a recently means in now present trend, and I've given examples also. Now coming to the next, the deployment scenarios for devices also, which we had discussed how we can deploy the devices with the microcontrollers, battery, power supply, everything that we had discussed, and in which type of projects and how we can deploy that in a different projects. One is a home alarms, which we have seen, and then a smart meters, which we have discussed about BESCOM project and all. So how you can do and all that we have discussed, and building automation systems, especially the motion detectors and all. So how it will be installed or a deployment can be done as a device that we have seen. And then we have discussed onboard units in a cars, robots, and autonomous, and video cameras, oil wells, and connected printers. So all these things we have discussed. Now we'll go to the basic devices in depth. The requirement on hardware are low, both in terms of processing, power, and memory. So when you will use a basic devices depends on your problem, or depending on your project problem, you will decide whether I want to use an advanced device or a basic device. So how a basic device will be there? Basic devices in terms of power and memory, it will be low. The main focus is on keeping the bill of materials as low as possible by using inexpensive microcontrollers with a built-in memory and storage. Especially when we use a basic devices, means when we can solve our problem, when a small problem will be there, we can solve, and less expensive it should be. Cost will also we are going to take into the consideration. So in that particular concept, we are dealing with this basic devices. For example, in a last class, just we have seen how the node MCU will be connected to the relay model, and then on and off using a blink you can do. What are the materials we have used with that? How much power supply is needed for that, and all if you take into the considerations. A node MCU will cost very less, and the relay it is around 100 rupees or 150 rupees just a cost. We are not bothering about a memory and all here. What is the thing we need here as means in a node MCU and all for a power and all, it will be there always in a house. So it will be connected to in electrical devices, and no problem will be there for a power and all. Means, for example, assume when power is needed in a drip irrigation, or in a drip irrigation when I'm deploying my particular device in a fields. So where power management is very much important, in that a long run power should be there. For example, I'm deploying my device in a forest, precious trees management. So there and all, so power is a very much important thing, and memory. It depends on so how many events you are going to record and how many events are there in your particular problem. Based on that, memory will also be an important one. So you can use additional memories also. So if that is the case, how you should use? For example, now what I told very simple. I want to switch on my fan or a bulb. Node MCU board I'll take, and I have one relay switch I will take for a node MCU board. I need just one plug-in and your mobile charger. which will works with the 5 to 6 volts. That is enough for me. So I'll connect that and I'll connect to your switchboard or that bulb, wires, whatever is there, directly I'll connect. Here, never I bother about a power. Why? Because it will be there always in a house. And I will never bother about a memory also. Why? Because memory aspect is not at all there here. What's a memory aspect? Nothing. So entire thing will comes in a mobile. So there on and off I can do wherever I may be. When I will press a on button, it should be on. So like that, if it depends on which type of a project you are doing and how you are doing that particular project. So either you can use a basic device or an advanced device. So inexpensive microcontrollers with built-in memory in a node MCU, built-in memory and storage will also be there, often on a SoC integrated circuit with all main components on one single chip. You have seen that node MCU always everything will be there in that particular thing. If you want, I will show you once again. Just a minute. Yeah, you can see this how simple it is. Means just yeah. See it. So this is one, right? So I can connect directly to my mobile charger. I will keep in a house like this, and it is having a Wi-Fi. Even it's having a Wi-Fi thing also in it. See, Wi-Fi connectivity is there. So nothing. I need this particular thing, and just I will connect to this pins. I will connect the relay, and I will put in one particular box, and I will put this to the plug, and the relay, whatever is there, I will connect it to the wires of my bulb, whatever is there, and my internet, whatever in a house internet will be there, hotspot, whatever will be there, that Wi-Fi and password will be put into the code, and it will be bought. So this will be always connected to the Blink server or whatever server, things speak. If I want, I can connect to that also. So then I will do in my app, I will do switching on and off. So these type of things when you do, that are the basic devices which you can use and you can do. Now, in a basic devices, what are the important things it will be there in depth in this particular node MCU only? If you see how these things will be there. Coming to first the ARM Cortex M3 CPU 24 megahertz. So this is very much important. Here in Node MCU they can use any other microcontroller, not an ISOs. Here very simple microcontroller will be there. Which will works. So that is the thing. Memory production unit, all these things will consider that particular stage, including this flash memory of how much 128 kbytes or 8 kbytes of SRAM it will use. And wired connectivity, UART it should be there, universal asynchronous receiver and transmitter, almost all boards, your Arduino, your Node MCU, or Raspberry Pi, or PKT boards, whatever it will be there, always it will work with a universal asynchronous receiver and transmitter. You can see RX and TX pins will be there always, which will do the communication. For example, if you want to connect to the Bluetooth or Wi-Fi, that things will be, it can be connected in that particular sense. Here everything is molded in Node MCU, but when you take a PKT board and all, you have to pin that using UART. You should connect for that particular thing. And coming to the next thing, you can see wireless connectivity will also be there, where it will work with lower bands will be there, and 8.2.15.4. Actually, this is a Wi-Fi which we are going to work. And analog will be there, ADC will be there. What is this 12-bit ADC? 6 channels will be there, almost all. But when you come to Raspberry Pi and all, there only digital pins will be there. When you come to the Arduino or Node MCU, even and I can say like the PKT boards and all, their analog pins, means some sensors will be there which will work in analog mode. So where you need a ADC, what is this ADC here? Analog digital converter will be needed, where analog data will be taken and it will be converted to the digital thing. So these components, and coming to the control, timers will be there always to control the events. You know, everyone. This in a microcontrollers, this plays a very much important role. Coming to the system over here, you can see how the power supply depends which power supply it is going to use, and the minimum how much power will be there here, oscillators and sleeper time, all these things. It will come under electronics, don't worry about that. But encryption will also be molded in that. Means when you are sending information out, and if you are receiving information out, and event manager will also be there. So this is about a basic device which you are going to use, like which I have shown an old MCU. Also, it will become one of the basic device which you can use. Now, in depth, if you see what will be there, the microcontroller typically hosts a number of ports that allow integration with sensors and actuators, 100%. GPIO pins will be there, such as the general purpose pins, and an analog to digital converter will also be there to support analog input. This plays a very much important role here. You can see in a Raspberry Pi 40 GPIO pins will be there, and here also you can see the pins, how many pins are there here, both including digital and analog pins is there in an MCU. In even the Arduino board, I don't have an Arduino board, and it will come on another 2 days. It's I put in Amazon. So it will come. So that even that will also support both digital and analog. So here, whenever the analog will be there, the PKT board will also be there. If you want, I will show the PKT board also. In 1 minute. Connected everything also. Yeah, you can see here how the different things will be there. Actually, it's yeah, you can see here. This is the separate Wi-Fi model will be there in a PKT and all. It's not like no MCU. It's molded one like that. You can have a Wi-Fi can be pinned at this particular stage here like this. This is a Wi-Fi which you can pin like this, and a Bluetooth will also be there. And you can see the Bluetooth also you can connect. There's a Bluetooth which I have connected. It's a Bluetooth board or a terminal which you can take into the consideration. And you can see LCD, how it has been done. Usually means Surya and somebody told like that's a LCD, no pins will be there like this. A jumper will come like this for an LCD, only holes will be there. Actually, to say in an LCD, only holes will be there. But here you can see this jumper will also come in a market separately. I think you are seeing this. This jumper will come separately. So you can fix this jumper and you have to do the soldering here. So like this, if you do the soldering, now this jumper with this particular female pins, female openings, you can connect to the board where the 16 pins will be there. So for there, you can connect clearly like this. So now every setup has been covered. This is a PKT board, and you can see here the microcontroller which is there, and you can see the pins beside this. These are the pins, 40 pins which is there here. I think you are seeing clearly, right? And almost all pins, whatever is there here, are analog pins. So DC also you can take, some options is there, and some analog pins is also there. And you can see this is the one regulator switch we can use, means to vary the values, analog means ADC values. And the ADC, small ADC will also be inserted here as a chip. So this is a one entire PKT board, which will also like your Raspberry Pi, Arduino, or whatever is here like this, it will work. And purely it is of microchip company. So here PKT, some microcontroller name will be there from a microchip. So you need a MP lab for deploying this particular projects. Software you can download easily, it's a open source. and then you need a separate bootloader must be there to burn that particular code into this particular chip, and you can do the coding here. If you know C programmers enough, so MC18 code will be used here, and C programming you can do. And different buttons also you can use if you want. One will be there for a reset. Remaining buttons you can use for your general purpose, like pressing a buttons as an events, like that you can do. Like this means what I mean to tell you that not only a theory part, so how a GPIO pins, general purpose input output pins, and what is the role of ADC will be there. So that things you can take into the consideration. For certain actuators such as motors plus width modulations, but it can also be used here. As a low power operation is paramount to battery powered devices, the microcontroller hosts functions that facilitate sleeping, such as interrupts that can wake up the device on external and internal events. 100%. Even in a node MCU or even in this particular Piketty board or Arduino, wherever it will be there, you can send a board to the sleep mode, a microcontroller to the sleep mode. Let it be you be in always sleep mode. When particular event occurs, then only wake up. Some problems will be like that. What are that type of problems? For example, I will tell you that accident problem means a project. In an accident project, always our node should be, our microcontroller should be in a working stage. No, it shouldn't be in a working stage. When it should be wake up, when some pressure will apply, it should wake up. You can write a code like that. Means some pressure will be there, automatically it will wake up and interrupts, and it will start working on with an external events. Like that, to why? Because power will be very low, you can utilize that particular power there. So that also one particular option which you can take. To interact with a peripheral such as storage or a display, it's common to use a serial interface such as SPI, I2C, or UART. So always we are going to use a UART. Even myself, I don't know that SPI and I2C. But UART I know. Why? Because we are all working with UART concept only. That is universal asynchronous receiving and transmitting will be done through one particular port. That is COM port, whatever maybe you are going to use, and just you are connecting that cable. For example, I will show you. See here in a PKT board, this is a power cable or a USB cable which they are going to give to you with that, sorry, with that particular board. And you can see I can connect this to my any of the charger if I want, or even a system if I want. Now this is bifurcated with you can see the wires here. I, I I think you can see this, right? And a black color wire, it will goes to the ground always, and red color wire will goes always with a power 5 volts power pin. And you observe these two things, which is very much important. What is these two things are? Well, the green color will always goes to the TX, and white color will always go to the RX. That is RX and TX connectivity is must in a PKT mode, which always works with the analog mode. So here what happens, so I am communicating with my board using a RX and a TX. But you can ask in a node MCU and all, once if you connect with that USB cable, that jump means whatever a USB port will be there, no female port, automatically their receiver and transmitter pin in, with that board itself, the connection has been gone. You can see in Arduino also, and even Raspberry Pi also. But here, this is a rare cable, so it will be separated like this always in a USB. You can use that also. So it's not usual for a microcontroller to also contain a security processor, example, to accelerate advanced encryption standard AES. So AES algorithm is an optional one which will be there in some boards. It will be there, or in some boards it will be not there. Usually, whatever boards are there in a market, almost all they will have one encryption techniques at least. Whatever data is going out from the device will go with an encryption, and there it will be received with other devices. Decryption will be done. Any of the algorithms, AES or DES, RSA, it will be used. Usually AES will be there. Because a basic device lacks a WAN interface according to our definition, a gateway of some form is necessary. Now here we should connect us to internet. Yes, I will connect to internet. Whether a WAN connection is needed for this. Means a big, like a big machines and all, which I should manipulate and I should do that and all. I need a WAN connections there. With the LAN only can I connect. Next topic will be on either when to use WAN and when to use LAN. So the gateway together with the connectivity devices from a capillary network means a small network also you can use and you can connect to the gateways means you can connect to the internet. Maybe speed of the internet will not much. I mean, you are using a less internet, and that's enough for my particular project which I'm going to use. The microcontroller contains most of the radio functions needed for communicating with the gateway and other devices in the same capillary networks. Means a small networks like your LAN. Even from LAN, I can connect to internet always. In our lab and all, we are having a LAN and we are able to connect to the internet. But when it comes to the vast companies and all, when WAN is needed, for example, India BMSIT has to connect to our ISP provider. There a WAN is needed. That means too much of traffic is there. That too much of traffic has to move in one particular lease line or one particular line. The WAN is needed. Now assume that, for example, you should first differentiate yourself with the WAN and the LAN when to use. All our projects, what we are doing, small projects and all now, LAN is enough for us. But when you need a WAN, for example, assume a big factory is there and that a production unit is there with some, I can say some 50 to 60 machines, and that machines, all machines should be connected over the internet, and another production unit is there or a processing unit is there where some machines are there in another place. Means assume in another city, so that should be connected together, and the main branch is there in some other city, that should be connected together, and you're doing an IoT project. In that particular sense, you need a separate lease line of internet. So many devices are there, how much traffic it's going to generate, means how much bandwidth it's going to generate, and how we should pass that particular thing. If you feel like that, for that and all, I will use my mobile hotspot. No, it's not possible. So for that, a separate leased line should be taken, and then you will place that. So that will city to city connection. My devices is there like that you can use. But here, whatever projects, small projects, and all we are doing, our internet means mobile internet you can take, or that is enough for us. Our Wi-Fi internet you can take. For that, the capillary networks is enough. Now, due to the limited computational resources, these devices commonly do not use a typical OS. 100%. We are not using any typical OS, but in advanced things and all, we are using typical OS. Means particular tiny OSs will be there for that, and that OS will look after other things and all. Raspberry Pi will stand in between. Hybrid like. It falls in advanced or it falls in a basic. But these, whatever node MCU, PKT boards, Arduino, it's all there, it falls under a basic devices. This side it will falls. But it may be something as simple as a single threaded main loop or an low-ended OS such as free real-time operating system or atom threads you can use or MFX RT like this. Erika Enterprise Tiny OS you can use both in this and that also. These operating systems offer basic functionalities, example memory and concurrency model management, sensor and radio drivers, threading, and TCP/IP protocol suite will be there automatically, and higher level protocol suites will also be there. So this is enough for me. For example, node MCU, Wi-Fi model, everything is there. When I will write a code giving a username and a password, and I will tell www.blink.com you connect, then automatically it will go and connect with a taken token. So how it will connect means that my device, whatever node MCU I am using, that should be identified in a network. That means my device knows TCP/IP stack. So even even Arduino, we are with Wi-Fi model, it will know. And this PKT, once if I have this connection, then automatically it also knows that. So like this, we can use the basic devices for a connection, means internet connections also. The actual application logic is located on top of the OS or in a main loop. Usually it will be in a main loop. Always, you know in Arduino and all, when you do it main loop coding only you will do. Here also we'll use a while and true and we'll do a coding. A typical task for the application logic is to read the values from the sensors. 100% we are doing that, and to provide these over the LAN interface in a semantically correct manner with the correct units. 100%. That's the only work. Sorry. Yeah, that's the only work actually our boards is also doing. Everyone will have projects here, and everyone you are having a practical knowledge also. What I mean to tell you that what is our application, actual application logic which we are doing. That means always I'll put my code in a mind loop and I will write a code like that. From sensor you bring this particular value and you run this actuator, something will write a code, and that code will transfer. You want to put in a cloud or things speak like that, will transfer through the LAN connection. This is a routine thing which we are doing. Next, gateways. Now here, what actually the gateways in this particular terms, if I want to tell you. A gateway serves as a translator between the different protocols. Example between 8.2.15.4 and 8.2.11. Both the things means which you can use an Ethernet or a cellular network. So how you are going to connect with these protocols to the network? There are many different types of gateways which can work on a different levels in a protocol layers. Most often, a gateway refers to a device that performs translation of the physical and link layer, but application layer gateways, ALGs, are also common. What actually gateway will do in our sense and all? In our sense, the gateway is very simple. The gateway is the one which will open a connectivity to the hotspot or something like that. From there, it will connect to that and it will send an information. So in my particular device, the gateway is this Wi-Fi model, which I can use, even a Bluetooth, which I can use as a gateway. But usually for internet and all, I am going to use this. And you can ask me the question, sir, LAN connectivity is not there here. Separate model I should put. Or GCM is not there. Separate model means board will come, GCM board. I have to connect to this particular thing. Even in Arduino also same thing, and even in Node MCU also same thing. If we want a GSM model, separate model will come and I should connect to the main board. So this particular concept, but in Raspberry Pi, I think GSM will not be there. So remaining all things will be there, means Bluetooth, Wi-Fi, everything will be there as a built-in. So you can connect. That's a one particular thing, means that's a gateways which we can consider. But here almost all in our boards we are having application layer gateways also, ALGs also. Some examples of ALGs are Zigbee gateway device. So Zigbee Alliance 2011, which translates from Zigbee to SOAP and IP, or gateways that translate from constrained applications protocols, COP to the hypertext transfer protocol, representational state transfer, HTTP to REST. So this particular concept, what actually is that how our particular board will transfer our whatever the data, means analog data, whatever taken from a sensor, it will be converted to the numerical or numbers, and then it should be transferred to the text. In what way it will transfer? Whether we are going to use a 6B alliances, this is one type of a gateway which we are going to use. COP is one type, and hypertext transfer protocol means COAP to hypertext we can use with a REST. Usually we are using almost all directly these gateways that translate from constrained application protocol, that is CoAP to the hypertext transfer, all in our board. But Zigbee also you can have not an issues. When you will have a Zigbee gateway device, I will tell you. Zigbee gateway devices we are going to use. Zigbee will work on 500 meters. That is, if you want to connect within a 500 meters with another particular device and all, and you want to send in a data. For example, assume that I want to do a IoT project that will communicate vehicle to vehicle. In that particular sense, I can use a Zigbee gateway device. Zigbee within some 200 meters max, it will work, where the internet may be needed in a later on stage. For example, if you want a scenario clearly of an example means I have told you that one, it means vehicular communication. If I want to adapt, so how we can adapt? Assume that in a remote place where a God section, some place will be there, an accident has been occurred. Usually, what happens once the accident has been occurred, somebody, even when we will see, they assume that, for example, no mobile connectivity is there in that particular forest area or some guard section. No, even no mobile connectivity will be there. An accident has been occurred. Just for a sake, I'm telling you, many places are there like that. Now, how you are going to intimate? Usually, all vehicles will keep on coming and going. Going to take a risk. This type of a problem will there, or somebody, even though in humanity they will step down and they want to call, means no mobile connectivity will be there at that particular place. Then how they will call to concerned police station or ambulance? 108, assume this is a problem. Now, for this particular problem, how you are going to give a solution in IoT concepts? Best, see, in my knowledge, I will tell you, you may think in a different way. Means a tree is bigger than a tree. So my idea for this is very simple like this. My vehicles will be keep on moving in that particular road, assume Siradi Ghat. Vehicles will be keep on moving. What I will do, once the accident occurs, my party, any vehicle will start broadcasting the emergency EMUs, means emergency message units. It will keep on broadcasting that, means it will keep on throwing out EMUs to this. Generally, all vehicles assume that this particular device will be there and it will be receivers will be there. In general, it will receivers. Once a force accident has been applied, for example, Shashank project only will take, either it will fall down or once a big force is applied on that, that means the accident occurred. Then automatically it will become a transistor, means TL, means it will transist the EMUs. Others, all in general, they will be receivers. Assume within a span of 100 to 200 meters, no mobile communication. You have to keep in your mind. This is very much important. So 100 to 200 meters, I will use the Zigbee there. So within that particular range, when vehicle comes, automatically EMU will go on. It will be EMU will be received from that particular vehicle. And that vehicle, once it receives a EMU, any emergency message unit it will receive, then automatically it should become a broadcaster and it should broadcast that to the next 200 meters or 100 meters. Within another vehicle is coming, assume 100, 200 meters, then in general everyone are receivers. So it will receive. Once it will receive a EMU, it will also become a transfer. But here a lot of constraints will be there. What is the constraints and all? Same EMUs will go to the different persons. If it is same EMU code, it has to discard that. sorry, once the EMU has been transformed to another vehicle correctly, it has, yes, it has been transformed in a forward range, then automatically it should become a receiver and it should go further. Now assume like this, what I will do, vehicle to vehicle, vehicle to vehicle, I will do a communication. When I'm doing this particular task parallelly, what I will do, I will check whether the mobile signal is there. Parallelly, I will check that. If mobile signal is not there, this type of transmission I will do. After doing like this transmissions, and assume what one particular vehicle, there is means mobile connectivity, automatically it will be there. A separate frequency will be there. So in that frequency, it will send an emergency message that EMU it will be. What EMU will contain? EMU will contain a longitude and latitude, a location of that particular place accident occurred, message will be there. So that will be transferred to the 108. So, or nearby police station. Either 100 or 108, both we will checking. So in both messages, EMU will go and from there ambulance will rush to the spot. You can ask me the question in this, what are the constraints? If what is the question and questions can be arised. Um, Vehicles density is very less. Anyway, we have to take a chance of that. Means if no vehicles are coming, that also no other solutions will be there. That's a one thing. Then another one thing is there like this. Assume vehicle density is okay. Every 5 minutes, once vehicles are keep on coming in that particular road, or like this. So our message will pass very early. That is, every 5 minutes is coming means every 200 meters, what vehicle will be there, which vehicle, any vehicle it can be. So it can keep on broadcasting. According to the survey, if vehicles are there very often, so within span of 5 to 10 minutes, the message will go to the 108. Instead of maybe it's a cost of a life when we leave the when accident occurred from 1 hour, 2 hours, 3 hours, no one has looked into that, and maybe the survival chance of that particular person is there, and even though no one has looked into that particular railway station or a transaction, it has been happened like that. Maybe better solutions you can also think of this particular problem. I'm telling where is it, we can be used and what, how a connectivity we can establish there. For that sake, I have told you that, and always it will works with the SOAP means broadcast means SOAP methods and all, and then that IP also it will works. Coming to next, for some LAN technologies such as 8.2.11 Wi-Fi and Z-Wave, the gateway is used for inclusion and exclusion of devices. Means you can connect the devices to the internet or you can take out. This typically works by activating the gateway into the inclusion or exclusion mode and by pressing a button on the device to be added or removed from a network. That you can do always. Coming to next, the data management in a devices. Typical functions for a data management include performing sensor readings and catching this data, as well as filtering, concentrating and aggregating the data before transmitting into the backend servers. So this is the data management which you have to do. Means you should have a room to code it and all. Means once the sensor data has been received, what actually the data has been reading, catching this data, cache memory will be there or flash memory will be there. First the data should go and sit there. Then what I will do, I will filter the data. Means I will keep a threshold values and all, you know this, threshold values and all I will keep. This type of data only I need. Concentrating on one particular type of data. Now, if that type of data will come, I will aggregate all that data to one side, and that aggregated data I can send to the cloud or a server, backend servers, whatever is there. In this way, the device level data management, I'm not telling full data management. Other data management, big chapter is there. In coming topic we will discuss. But here, device level data management is only this much. At the device level, we'll take that particular data. We'll check is this a required data for me? Yes, this is required data for you. I will take filtering. Then concentrating on that data. Yes, this is okay. Data are there. Aggregate all the data. Now, coming to the next, local applications. Examples of local applications that can be hosted on a gateway include closed loops, home alarm logic, and ventilation controls of data management functions. Small things, local applications we can connect to this type of gateways. To facilitate the efficient management of applications on a gateway, it's necessary to include an execution environment. The execution environment is responsible for the life cycle management of the applications, including installation, fuzzing, stopping, configuring, and uninstallation of the applications. When my application should work, or when this particular code should work, and when this code should be fuzzed, when this code should be stopped, or when this code is enough. It's worked one time. I don't want again to work, uninstall automatically. Like this, when you want to do all those things through your cloud or through that gateway only, you have to do that. Means what should be sent and sorry, what should be sent and what not should be sent. Sorry. Yeah, that's a one thing. And then a common example of an execution environment for an embedded environment is OSGI, which is based on Java, which you can Google it and you can see it. Applications are built as one or more bundles, which are packed as a Java jar files. Always it will be like a jar files we can open. You must have a Java, any version of SDK should be there for to open that. If once it is there in your operating system, the jar file you can run directly. You run through Java. So if you run that, you will get this particular OSGI. So where you can manage the agents in that particular control, for example, terminal shell or something like that, you can manage the things. Or when it will comes into the picture, no, when you are having a several sensors and you have placed a several sensors and that sensors is communicating with one sync node, and from that sync node, if you are collecting a data and these type of operating systems or gateways you need. But usually one or two sensors we are doing, and our board is enough to do with that. Really, it's not a real time. But when it comes to a real time, how many sensors you have to put? These many sensors, if I will put as a large sensors, how it should communicate. That is a sync node should be there always. From there, how I can connect to a main board. These things will be a different one. Coming to the gateways, the device management. Device management is essential part of the IoT and provides an efficient means to perform many of the management tasks for devices. Provisioning, initialization of devices in regards to configuration and features to be enabled. So always provisioning should be there when I will switch on my particular device. So initialization means my device should configure itself, boot itself. So afterwards, whatever the features I have enabled, whatever the code I have run, it should run automatically. Device configuration, management of device settings and parameters. Means always how the device configuration I will do in that particular sense. Means when to connect to Wi-Fi, when to connect to GSM model, or when to connect to the LCD, when to connect to the Bluetooth. So software upgrades means if I want to upgrade my Bluetooth driver or any Wi-Fi drivers, new drivers are there. If I want to upgrade that, it should be possible to upgrade that. Fault management, any enables errors reporting and accessing to the device status. If something happens, short circuits happens within a node and all, it should be like that. It should report that. So in advanced devices, how the gateways device management will be there. Powerful CPU or microcontroller with enough memory and storage to host advanced applications. as I told you that many machines of a factory to be connected, such as a printer offering functions for copying, faxing, printing, and remote management. And a more advanced user interface with, for example, display and advanced user input in the form of a keypad to touch screen or video or other high bandwidth functions if you are doing. For that, you need advanced devices, especially for video streaming, video motion capturing. Why? Because video itself needs a more bandwidth, like that. So that's a one thing which is there. Then local and wide area networking. First, we in local and wide area networking, we'll go for a need for a network, and we'll see that why network is needed before going to local and wide area networking. We'll see in our IoT projects what's the role of network, why network is needed, and how to make this network. And later on, we will see how a LAN is needed, capillary network is needed in which place, and wide area network is needed in which place, and how to deploy these networks. That we are going to see in a coming session. Okay, now for this period or in a class, I'll stop here. Uh, we'll discuss in a next coming classes. Just I'll stop there. Yeah, just 1 minute. Yeah. Now, you see here, I'll share one link of the quiz. I will put an attendance, just 5 questions, MCQ questions. You can answer it, I think. I'll share the link. You answer that particular quiz questions, right? Send. Chart looks. Right. Now, how was the session? What is your feedback? Any doubts are there? Any doubts are there? Answer.
No, sir.
How was the session? Did you have any doubts with that Piketty board, Node MCU, what I have shown you? Any doubts like that? How a Wi-Fi separately will be pinned? Huh? Any doubts?
No, sir.
Right. So you go with that quiz. Meanwhile, I'll take an attendance. First, I'll keep the ingredients. Just a minute. Aditya,
Yes, sir.
Ajay,
Yes, sir.
Amit,
Yes, sir.
Antima.
Present, sir.
ಯಾಕೆ ಲಾಸ್ಟ್ 2 ಕ್ಲಾಸ್ ಅರ್ಜೆಂಟ್ ನೀನು?
Sir, I was not well, sir.
Not well.
Corona.
ಅಪೂರ್ವ, ಅಪೂರ್ವ ಇಲ್ವಮ್ಮ? ಅಶ್ವಿನಿ,
Yes, sir.
ಬಿಂದು,
Yes, sir.
ದಿವ್ಯೇಶ್, ದಿವ್ಯೇಶ್, what happened to him? Gaurish, Gaurish,
Yes, sir.
ಇಲ್ವಾ?
Yes, sir.
ಗೌತಮಿ,
Present, sir.
ಗುಣಶೇಖರ್,
Present, sir.
ಹರಿಣಿ,
Present, sir.
Surya,
Present, sir.
Naina, Nazma,
Present, sir. Present, sir.
Nini, Pradeep,
Present, sir.
Sir.
Preeti.
ಪ್ರೆಸೆಂಟ್ ಸರ್.
Last class ಯಾಕೆ absent Preeti?
ಐ ಇನ್ಫೆಕ್ಷನ್ ಆಗಿತ್ತು ಸರ್.
Rajesh, Sahadev,
Present, sir.
Saket.
Present, sir.
What happened to him? Saket,
I was not well, sir, for last 2 days.
attend regularly. You are having a less attendance, Saket. Santosh, Seema,
Present, sir.
Sinchana,
Yes, sir.
Present, sir.
Spurti,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
Varsha,
Present, sir.
Yashaswini,
ನಂದು ಶುರು.
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ನಿಂದ್ ಬಿಟ್ಟ ಶಶಾಂಕ್ ಬಂದಿದೆಯಲ್ಲ ವರ್ಷ ಬಂದಿರ್ಲು
Present, sir.
ಯಶಸ್ವಿನಿ ಇಲ್ವಲ್ಲ ಇದ್ದಾಳೆ ಯಶಸ್ವಿನಿ ಹಾ ಅಮೃತ ಅಮೃತ ಕೇಳಿಸ ಅನುಷಾ
Present, sir.
Present, sir.
ಅಪೂರ್ವ ಕೆ
Present, sir.
ರೈಟ್ ಸಾಯಿ ಸಿದ್ಧಾರ್ಥ್
Yes, sir.
ಚೇತನ ಕೆ ಚೇತನ
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಕಾವ್ಯ ಕೆ
Present, sir. ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಚೇತನ ನಿಂದಾಯ್ತು ಕಾವ್ಯ ವೈ ಕಾವ್ಯ ಕಾವ್ಯ ಕೇಳಿಸ್ತಾ ಇದೆಯಾ ಕಾವ್ಯ ರಿಪೀಟ್ ಮಧುಶ್ರೀ
Sir, she just got disconnected, sir. Power problem, sir.
ಅಪೂರ್ವ ಕೆ ಹಾಕಿದ್ದೀನಮ್ಮ ಪ್ರೆಸೆಂಟ್ ನಿನಗೆ
ಸರ್ ಮಧುಶ್ರೀದು ಸರ್ ಮಧುಶ್ರೀದು ಅವ್ರ ಕ್ಲಾಸ್ ಈಗ ಡಿಸ್ಕನೆಕ್ಟ್ ಆಗಿದೆ ಅಂತೆ ಸರ್ ಪವರ್ ಪ್ರಾಬ್ಲಮ್ ಇಂದ.
ಓಕೆ ಓಕೆ ಕಾವ್ಯದು ಕಾವ್ಯ ಇಲ್ಲಿ ಇರ್ಲಿಲ್ಲ ಅಲ್ವಾ
ನೋ ಸರ್.
ಸರಿ ಮನೀಶ್
Present, sir.
ಸಾರಿ ಸರ್ಫರಾಜ್
Present, sir.
ಮುರುಗೇಶ
Present, sir.
ಮಣಿ
Present, sir.
ಪರೇಶ್
Present, sir.
ನಿನ್ನೆ ಕ್ಲಾಸ್ ಹಾಕೋ ಬಂದಿಲ್ಲ
ಇದ್ದೆ ಸರ್.
ಆ
ಇದ್ದೆ ಅಲ್ಲ ಸರ್ ನಿನ್ನೆ.
ಪೂಜಾ
Present, sir.
ಪ್ರಶಾಂತ್ ರೆಡ್ಡಿ
Present, sir.
ಪ್ರತಿಭಾ
Present, sir.
ಪ್ರತೀಕ್ ಇವ್ರು ಆಮೇಲೆ ನಾನು ಇದ್ದೀನಿ ಅಂತಾನೆ ಪ್ರತೀಕ್ ಸಾಧನಾ ಐ ರಿಪೀಟ್ ಸಾಧನಾ ಶಶಾಂಕ್ ಶ್ರದ್ಧಾ
Present, sir.
ಶ್ರೀಧರ್
Present, sir.
ಇವ್ರು ಯಾರು ಇಲ್ವಾ ಪ್ರತೀಕು ಸಾಧನಾ ಶಶಾಂಕ್ ಇಲ್ಲ ಅನ್ಸುತ್ತೆ ತನೋಜ್
Present, sir.
ತೇಜಸ್ವಿನಿ
Present, sir.
Ani,
Present, sir.
Ani, Ani, ಇಲ್ಲ ಅಲ್ವಾ? ಹುಮಾಯನಿ ಇಲ್ಲ. ಆಶೀಶ್
Present, sir.
ಕ್ಲಾಸ್ ఎందుకు ಆಬ್ಸೆಂಟ್?
Sir, health issue, sir. Health issue, sir.
ವಿದ್ಯಾರಾಣಿ,
Present, sir.
ವಿಶಾಲ್,
Present, sir.
ಕ್ಲಾಸ್ you are absent.
No, sir, I was present, sir.
You doesn't tell the attendance.
Sir, afterwards I told attendance, sir.
Okay. So any doubts regarding a project also you can call me anytime, not an issues. We'll do that. Amrita,
Yes, sir.
ಏನಾಯ್ತಮ್ಮ ಅದು ಚೆಕ್ ಮಾಡ್ದ ಮಲ್ಟಿಮೀಟರ್ ಇಂದ?
ಇನ್ನು ಚೆಕ್ ಮಾಡ್ಲಾ ಸರ್, ಸಿಕ್ಕಿಲ್ಲ, ಚೆಕ್ ಮಾಡಿಸ್ತೇನೆ.
ಅದು ಸಿಗತ್ತೆ. ಯಾರಾದ್ರೂ ಒಂದು ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಅಂಗಡಿಗೆ ಹೋದ್ರೆ ಟಿವಿ ರಿಪೇರಿ ಲೈಕ್ ದಟ್ ಅವ್ರ ಹತ್ರ ಇರುತ್ತೆ ಮಲ್ಟಿಮೀಟರ್. ಆ ಬ್ಲೂಟೂತ್ ಇದು ಬಯೋಮೆಟ್ರಿಕ್ ಎಕ್ವಿಪ್ಮೆಂಟ್ ಅಲ್ಲಿ ಪವರ್ ಎಷ್ಟು ರಿಕ್ವೈರ್ಮೆಂಟ್ ಇದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ ಫಸ್ಟ್.
ಅದು ಗೂಗಲ್ ಮಾಡಿದ್ರೆ ಸರ್, ಸೇಮ್ ಹಾಕಿ ತಗೊಂಡಿರೋದು. ಆ ಫಿಂಗರ್ ಪ್ರಿಂಟ್ ಅಲ್ಲಿ ಎಷ್ಟಿತ್ತು?
3
ಅದು ಫಿಂಗರ್ ಪ್ರಿಂಟ್ ನೇಮ್ ಹಾಕಿ ಗೂಗಲ್ ಮಾಡಿದೆ, ಅದು ಸೇಮ್. ಯಾವ್ದು ಫಿಂಗರ್ ಪ್ರಿಂಟ್ ಅಲ್ಲಿ ಎಷ್ಟಿತ್ತು ಅಷ್ಟೇ ತೋರಿಸ್ತು. 3.3 ವೋಲ್ಟ್ ಅನ್ನೇ ತೋರಿಸ್ತಿತ್ತು ಗೂಗಲ್ ಅಲ್ಲಿ ಸಹ.
ಬಟ್ ಯಾಕೆ ಪವರ್ ಸಪ್ಲೈ ಆಗ್ತಾ ಇಲ್ಲ ಅದಕ್ಕೆ?
ಮೋಸ್ಟ್ಲಿ ಅದೇ ಹೇಳಿದ ಸರ್, ಅದು ಫಿಂಗರ್ ಪ್ರಿಂಟ್ ಸೆನ್ಸರ್, ಅದು ಲೈಕ್ ಪಿನ್ಸ್, ವೈರ್ ಪಿನ್ ಇರ್ತದೆ, ಸೊ ಲೂಸ್ ಕನೆಕ್ಷನ್ ಆಗ್ತಿದ್ಯಾ ಅಂತ ಒಂದು ಡೌಟ್ ಇದೆ.
ಅದನ್ನ ಸಾಲ್ಡರ್ ಮಾಡಿಸ್ಕೊಂಡು ಬಂದ್ಬಿಡಿ ಅಲ್ಲೇ ಹೋಗ್ಬಿಟ್ಟು. ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಅಂಗಡಿಗೆ ನೀವು ಹೋದ್ರೆ ಅವರು ಸಾಲ್ಡರ್ ನಿಮ್ಮ ಹತ್ರ ಇರಲ್ಲ, ಸಾಲ್ಡರ್ ನಿಮ್ಗೆ ಮಾಡಕ್ಕೂ ಬರಲ್ಲ. ಸಾಲ್ಡರಿಂಗ್ ಇಟ್ಸ್ ನಾಟ್ ಸೋ ಈಸಿ. ಮೀನ್ಸ್ ಒಂದು ಅಟೆಂಪ್ಟ್ ಒಂದೇ ಅಟೆಂಪ್ಟ್ ಅಲ್ಲಿ ಮಾಡಕ್ ಬರಲ್ಲ, ಸುಟ್ಬಿಡ್ತೀರಾ ಬೋರ್ಡ್ ನ. ಅದಕ್ಕೆ ಅವ್ರನೇ ನನಗೆ ಈ ಒಂದು ಬಯೋಮೆಟ್ರಿಕ್ ಡಿವೈಸ್ ನ ಈ ಬೋರ್ಡ್ಗೆ ಈ ಪಿನ್ಗೆ ಕನೆಕ್ಟ್ ಮಾಡ್ಕೊಡಿ ಅಂತ ನೀವು ಹೇಳಿದ್ರೆ ಅವರು ಸಾಲ್ಡರ್ ಮಾಡಿ ಕನೆಕ್ಟ್ ಮಾಡಿ ಕೊಡ್ತಾರೆ ನಿಮ್ಗೆ. ಟ್ರೈ ಮಾಡಿ ನೋಡಿ. ಇನ್ಯಾರಿಗಾದ್ರೂ ಏನಾದ್ರು ಡೌಟ್ಸ್ ಇದೆಯಾ ಪ್ರಾಜೆಕ್ಟ್ಸ್ ಅಲ್ಲಿ?
ಸರ್,
ತೇಜಸ್ವಿನಿ
ಮಾತಾಡ್ತಿರೋದು.
ಹೇಳಮ್ಮ.
ಸರ್, ಅಲಾರಾಮ್ ಜಾಸ್ತಿ ಸೌಂಡ್ ಅಂದ್ರೆ ಯಾರೋ ಬರ್ನ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರಲ್ಲ ಸರ್.
ಏನಮ್ಮ, ಜೋರಾಗಿ ಮಾತಾಡಿ.
ನೀವು ಸ್ಟೆಪ್ ಡೌನ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಯೂಸ್ ಮಾಡಕ್ ಹೇಳಿದ್ರಲ್ಲ. ಹಲೋ, ಅದಕ್ಕೆ ಸಪ್ರೇಟ್
ಯಾವ್ದಕ್ಕೆ
ಅಲಾರಾಮ್ ಜಾಸ್ತಿ ಸೌಂಡ್ ಬಂದ್ರೆ ಬರ್ನ್ ಆಗುತ್ತೆ ಅಂತ ಅಂದ್ರಲ್ಲ.
ಇದು ನಿಮ್ಗೆ ಅಲಾರಾಮ್ ಜಾಸ್ತಿ ಬೇಕಾಗತ್ತೆ ಅಂತ, ವೋಲ್ಟೇಜ್ ಜಾಸ್ತಿ ಬೇಕಾಗತ್ತೆ. ನೀವು ಅಲಾರಾಮ್ ಸೌಂಡ್ ನಿಮ್ಗೆ ಜಾಸ್ತಿ ಬಜಾರ್ ಜಾಸ್ತಿ ಬೇಕು ಅಂದಾಗ ಪವರ್ ಜಾಸ್ತಿ ಬೇಕಾಗುತ್ತೆ. ಅದಕ್ಕೆ ನೀವು ಸ್ಟೆಪ್ ಅಪ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಹೇಳಮ್ಮ.
ಸರ್, ಸೆಪರೇಟ್ ಸರ್ಕ್ಯೂಟ್ ಮಾಡ್ಬೋದಲ್ವಾ?
ಸಪರೇಟ್ ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲ, ಒಂದು ಬೋರ್ಡ್, ಚಿಕ್ಕ ಬೋರ್ಡ್ ತರ ಬರುತ್ತೆ ಅದು. ಅದನ್ನ ನೀವು ನಿಮ್ ಬೋರ್ಡ್ಗೆ ಕನೆಕ್ಟ್ ಮಾಡ್ಕೋಬೇಕು. ಅರ್ಥ ಆಯ್ತಾ? ಅದು ಸ್ಟೆಪ್ ಅಪ್ ಆಗ್ಲಿ ಸ್ಟೆಪ್ ಡೌನ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಆಗ್ಲಿ ಒಂದು ಸಪರೇಟ್ ಈ ಯಾವುದು ರಿಲೇ ಮಾಡೆಲ್ ತರ ಬರುತ್ತಲ್ವಾ, ಸಪರೇಟ್ ಬರುತ್ತೆ. ಅದನ್ನ ನೀವು ಕನೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡು ಅದ್ರ ಮುಖಾಂತರ ನೀವು ಈ ಬಜರ್ ಕೊಡ್ಬೇಕಾಗತ್ತೆ ಅಷ್ಟೇ. ಬಿಟ್ವೀನ್ ಬೋರ್ಡ್ ಅಂಡ್ ಬಜರ್ ದಟ್ ವಿಲ್ ಕಮ್, ದಟ್ಸ್ ಇಟ್.
ಓಕೆ ಸರ್, ಹಾಗೆ ಮಾಡಿ.
Any other doubts?
Thank you, sir.
See, I am also a learner here. Means according to my knowledge, whatever I searched in YouTube and Google and all, the basic with that particular knowledge only I am telling. Means any other your friends are there, electronics students are there, where they are keen in doing this type of boards and all, definitely they will help you. I will also asking my friends that person which we have met in our class, Chandrakant sir, or Chandru sir, whoever is there. You do all your things. One day we'll make a problem session. I will invite him. Each one of you, you show your problem to him. He will give a suggestions what is the problem in that and all. In between when you can keep that, if you tell me, I'll ask him if he is free one day, according to his free time, we will fix. He will solve your each and every doubts. I think means more than me. He knows each and every pin how it works. Means about hardware and all. He knows very well. I'll make that arrangements. So before that, you must be thorough with your doubts. Means if you solve that doubts, meanwhile we can't call him. If you solve that particular doubts, it should be very easy to you to go make that project. In that stage, you should be always. Okay. Okay. ಆಗ್ಲೇ ನೋಡಿ ಎಷ್ಟು ಜನ ಹೊರಟೋಗಿದ್ದಾರೆ, ಬರೀ 13 ಜನ ಇದ್ದಾರೆ. ಇಷ್ಟು ಜನಕ್ಕೆ ಮಾತ್ರ ಇಂಟ್ರೆಸ್ಟ್ ಇದೆ. ಓಕೆಪ್ಪ, I'll stop recording. Right. 1 minute.
Sir.
Seema.
Sir, we are not getting code, sir.
What, ma?